Example 4 says, a rowboat is pulled toward a dock from a bow through a ring on the dock 6 feet above the bow. If the rope is hauled in at a rate of 2 feet per second, how fast is the boat approaching the dock when 10 feet of rope are out? So the first thing was to draw a sketch, but the sketch has been provided for us, so we don't do that. The second step is to write down in calculus notation the rates we know and the rates we need to find. So we said, if the rope is hauled at a rate of 2 feet per second, how fast is the boat approaching the dock? Okay, so here is the boat. So if we label the distance from the boat to the dock with any letter, I'm going to label it with X, we know that we are looking for dx dt. So how fast is it approaching the dock? And then we said that the rope is being hauled in at a rate of 2 feet per second. So this right here, and we'll call this distance R, is being hauled in at a rate of 2 feet per second. So now what we need to do is write an equation that's going to relate the variables. Well, if we look, this is a right triangle. Now, this 6 feet will never change because the dock is always going to be 6 feet above the water. So this 6 feet won't change, but we need an equation that's going to relate all my variables. Well, this is just Pythagorean theorem, and we know that x squared plus 6 squared is going to equal r squared. So we know that x squared plus 36 is equal to r squared. And now if we take the derivative, we're going to have enough information to solve for this. So let's see what happens. We have 2x dx dt plus the derivative of 36 is 0 is equal to 2r times dr dt. Well, I know what dr dt is. That's given. I'm looking for dx dt. So now I just need to know, did it tell me what x and what r is? What is x and what is r? Well, it says, how fast is the boat approaching the dock when 10 feet of rope is out? So that means that r is going to be equal to 10 feet. So how do I find x? Well, again, this is just a right triangle. If I know what r is equal to, I can find x. So what we're looking at is we're saying, okay, this is 6, this is 10, and this is x. So to find x, we know that x squared plus 6 squared is going to equal 10 squared. So x squared plus 36 is going to equal 100. Subtract 36 from both sides and we get x squared is equal to 64. Taking the square root of both sides to solve for x, and we end up with x is equal to plus or minus 8. But we know that we can't have a negative distance, so we know that x is just going to equal 8. So now we have all the information needed to solve for dx dt. So plugging in, we know that 2 times 8 times dx dt, that's what we're looking for. We don't need our plus 0, is going to equal 2 times r is 10 times dr dt, which is equal to 2. So we end up with 16 dx dt is equal to 40. Divide both sides by 16 and we get that dx dt is equal to 40 over 16, which reduces to, both are divisible by 8, 5 halves. So let's go back and look at the information. It says, how fast is the boat approaching the dock? So the distance between the boat and the dock we know is decreasing, right? Because the boat is approaching the dock. So this distance is going to be decreasing. So since that distance is going to be decreasing, we know that the boat's is going to be approaching it since it's decreasing negatively. So we have negative 5 halves feet per second as our answer. Or if it had said decreasing, we would just say that our answer is 5 halves feet per second. Let's look at number 5. Number 5 says, suppose that for a company manufacturing calculators, the cost, revenue, and profit equations are given by the following, where the production output in 1 week is X calculators. So here's my cost, here's my revenue, and here's my profit function, and I know that production output in 1 week is equal to X calculators. if production is increasing at a rate of 600 calculators per week, well, remember, production output in 1 week is called X, so that means that dx dt is equal to 600 calculators per week. When the production output is 2,000 calculators, we want to find the rate of increase or decrease in the cost, revenue, and profit functions. So I need to find the rate of increase or decrease in cost, which means I'm looking for dc dt, revenue, which means I'm looking for dr dt, and profit, which means I'm looking for dp dt. So let's go ahead and work all this out. This one's easy because our equations are already given for us, so we don't need any work to find our equations. So let's start with trying to find the rate of change in the cost. Well, I know that my cost function is c is equal to 8,000 plus 30x. When I take the derivative of this, I'm going to have a dc dt is equal to, well, the derivative of 8,000 is 0, plus the derivative of 30x is just 30, and then we took the derivative of x, which is dx dt. Do I have enough information to solve this? I sure do, because I am told that dx dt is equal to 600. So then dc dt is going to equal whatever 30 times 600 is. In this case, it's going to be 18,000. So my cost is increasing at a rate of $18,000 per week. So let's look at the next one, which would be the revenue. Now recall revenue, dr dt, and my revenue function is given as r is equal to 300x minus, and another way of writing x squared over 20 is 1 over 20x squared. Taking the derivative here, and we get dr dt is going to equal, well, the derivative of 300x is 300, and I just took the derivative of an x term with respect to time. The derivative of 1/20th x squared, if I multiply this 2 there, 2 over 20 reduces to 1 over 10 x, and I just took the derivative of an x term with respect to time. Then I have enough information to solve for dr dt. So I say 300, remember dx dt is 600, minus 1/10 x. Am I given x? I am. I'm told when the production output is 2,000 calculators. So I'm told that x is equal to 2,000. And again, dx dt is equal to 600. So then the rate of change in my revenue is going to be, grabbing a calculator, we have 300 times 600 minus 1/10 times 2,000 times 600. And we end up with 60,000. So our revenue is increasing, because it's positive, at a rate of $6,000 per week. Finally, we're asked to find the rate of change in our profit. And profit is dp dt. Well, our profit function is given as p is equal to r minus c. So the derivative of p is going to equal dp dt. The derivative of r is dr dt. The derivative of c is dc dt. And I know what dr dt is. We found that to be 6,000. And I know what dc dt is. It found that to be 18,000. So we can solve for dp dt, or the rate of change of my profit. It's just going to be whatever 60,000 minus 18,000 is. So the rate of change in my profit is going to be $42,000 per week. Okay, let's look at our last one, number 6. Number 6 says, a retail store estimates that weekly sales, S, and weekly advertising, X, both in dollars, are related by that following equation. S is equal to 50,000 minus 30,000 e to the negative 0.00025x. The current weekly advertising costs are $4,000, and these costs are increasing at a rate of $400 per week. Find the current rate of change of sales. So a picture is not going to help me here, so let's take a look at what we're told again. Remember, S is your sales, and X is advertising. And so my sales and advertising are represented in this equation. And it says the current weekly advertising costs are $4,000. So that means that X is equal to $4,000. And these costs are increasing at a rate of $400 per week, which means dx dt is equal to $400 per week. Find the current rate of change of sales, which means I'm looking for ds dt. So what is ds dt? Well, I'm already given the equation, so part 3 is done for me. So I just know that I need to find the derivative of s is equal to 50,000 minus 30,000 e to the negative 0.00025x. So let's find the derivative. Well, I know that ds dt is going to equal, the derivative of 50,000 is 0. Now this 30,000 here is a constant multiplier. It multiplies along, so 30,000. The derivative of e to a function is e to that function times the derivative of the function. Well, the derivative of negative 0.00025x is just negative 0.00025. So now if we just clean this up, a negative times a negative is a positive. And let's grab a calculator and figure out exactly what 30,000 times 0.00025 is. So 30,000 times 0.00025, and we end up with 7.5. So ds dt is equal to 7.5 e to the negative 0.00025x. And you know what we forgot to write here? We just took the derivative of an x term with respect to t, so times dx dt. So it was the only thing we had forgotten to write. After we took the derivative, we forgot to put dx dt because we had taken the derivative of an x term with respect to t. Now just plug in the known information and solve for ds dt. So we get 7.5 e to the negative 0.00025. And then here we said that x was equal to 4,000 times dx dt, which we know is 400. So in a calculator, we would write 7.5 times e raised to the negative 0.00025 times 4,000. And then all of that multiplied by 400. And to the nearest dollar, we're going to say that this is 1,100 and rounding up to $4 per week. So the rate of change in my sales is going to be $1,104 per week. Well, that's it for section 3.6.